Good evening. Today is January 27, 2020. Today, this is the stand up for the hashtag CS24 underscore Tico group. There's the man, Luis himself. We're getting started. All right. Obeda and Catherine in the house. Okay, today was the first day of computer architecture. So what do we think? How do we feel? Wait for.
Well, Luis already built a computer, so I feel
Yeah, that's true. That's true. Brady said today Brady said today that this was the closest that you could get to like the actual hardware metal. I'm like, nah, Luis got closer. Yeah, he got closer. Get closer, oh, get closer. It's the feelings now. Oh, Chimo. All right.
Building a PC is kind of like building something from IKEA. As long as you follow the manual, it's fine. So it's cool to see how like all these parts I put together are actually like communicating. But that's really the only.
I think it's funny how you're downplay. I think it's funny how you're trying to downplay putting a computer together because if you told my mother-in-law that, she'd think you're full of spaghetti. She had to call me to come over to change channel for her. So, Brent. All right. We're still waiting for Jade and for Tiny. Let's see. Jade. Miss Jade. Oh, yeah, there she is. All right. Okay. Tiny is, I think she had to take care of something, but we'll go ahead and get started here. Let's go 60 seconds breakthrough. I'm going to start for a quick change just because yesterday was a tough day for me. If you guys didn't already see on the news, Kobe Bryant passed away. His daughter was also in the helicopter that crashed yesterday. And I know people are like, it's not that big of a deal. Like, he's just a basketball player, but this basketball player, he was like Superman to me. He's like a childhood idolized hero on the basketball court, and basketball was like my life before I met my wife in that picture right there. So now my wife is my life and my daughters, but yeah, before it was like Kobe got me through a lot of difficult times. Basketball court. Oh, there's Tani. Okay, so I will popcorn to Tani.
Hey guys. So I am decided I'm going to flex so that I get a stronger base for graphs and everything. I don't like barely hitting deadlines, which is what I've been doing for CS. But yeah, it was great being in a team with you guys, and I hope everything goes well for you all. Yeah, I can't hang out too long tonight because I'm doing a family dinner, but just want to check in and say hi. And good luck to you all.
Oh, we're going to miss you.
Good luck, Tani.
Yeah, good luck.
Good luck.
Thanks, guys. I'll see you hopefully around, if not in the higher channel.
In the higher channel. Woo. All right, Tani. Bye. Anytime you need anything, you know what channel to call.
I do. Thanks, guys. Bye.
See you. Should popcorn somebody right before you leave, but maybe not. Okay, let's go with Beta this time because he's always.
I have a big head, so sometimes it's like cracking my neck when I do that. Yeah, so I actually had a breakthrough. Thank you, Tico. I'm apparently really bad with Biden. It feels like I wasn't even at the lecture, even though I was at the lecture. And so like I just was really thrown off today with just the ones and the zeros, and I just couldn't do the math. And then I realized that it's 2 for well, I realized after Tico off the call, and I started watching again. I don't know why it never clicked. And on top of that, the spec didn't help me at all. That just threw me off for a loop. But I understood, and I got the code to work. So I guess that's my breakthrough. Yeah. So I'm not a fan of computer architecture at the moment. So yeah, it's my update. Also, similar to Tico, yesterday was also a big basketball person here. So that was, and I do live in SoCal. So this was it was an interesting day yesterday. It was like a shock for everyone because, I mean, whether you like him or not, he was like an icon. But anyways, so I will popcorn to Catherine.
Breakthroughs, I guess, was not being like completely scared out of my mind out of this README, which had like, it was just like as if it was in another language, you know? So I just like took the time, like the hour he suggested, just to like read through everything and like read through the spec. And then as I was like reading through it, I started to like understand and like put things together. Because at first I was like, what are these? There's an I and there's an A and there's a B and an R. And I was like, what is going on? And then it kind of like, as I went through it, it kind of all came together. So, and I thought for me, the videos in the TK with Beige, actually, I thought were really, like, that was more clear for me than what Brady was doing. But I obviously used Brady's code to do the code for the assignment. So, yeah, so just getting more reps in, I guess. And I will popcorn Luis. Thanks me.
So breakthroughs. I got stuck on one part, but I sort of cruised through this. I think I took the time to break down the actual what the binary was doing. I read through the spec, and I opened up like a little notepad as I was going, and I was just before it even went through. So the print8 file, I had already like broken it out and said, okay, this calls LD1, and then found what LD1 was in the spec or LDI, and then I did that for each instruction, just like, okay, I think this one's the address, I think this one whatever. So I had a pretty good idea of what I was supposed to do before I even like started coding, but I ended up getting stuck on print because I think just the way I wrote my RAM read function returns a value, and when I was trying to print, I was just printing that value instead of printing like the value. I was thinking that value, which was an index, instead of the value at that index.
Right.
So as soon as I like adjusted it, everything worked, and it was pretty cool. But kind of excited for tomorrow.
Cool, man. It's cool.
I'll popcorn Jade.
So my breakthrough is kind of a continuation of what I was doing this weekend. For the sprint challenge, I have been forcing myself to write comic questions as I'm going through parts I don't understand, so that I can kind of, instead of trying to rely on other people, get myself to like think deeper about the problems and then find my own answers, be a little more self-reliant. So after spending like an hour going through everything, I kind of did the same thing of just asking questions. And by asking those questions, it kind of leads me to answers by myself. So that's kind of my breakthrough. And that's about it. Just kind of exhausted because I finished the sprint yesterday. So that's it.
Yeah. Did a really good job too.
Thank you.
900 some moves. Yeah, it's good. Great.
Let's see. I guess who's left? Bryant, Popcorn Bryant.
Okay. I guess per usual, I'm still getting going. Using my West Coast time zone full advantage. But yeah, I don't know. I've just spent a lot of time reading. Yeah, trying to read through the instructions.
You don't have to be so humble about it. I mean,
And
like you had to deal with a lot this past weekend.
yeah, I do have to deal with
Yeah.
a lot. Yeah, yeah. It's been like a long 2 weeks for me with my wife getting surgery and like the kids and stuff.
So how many times do you have to do a fireman's carry with your wife up the steps? How many times a day?
Not that many times a day, just
okay.
only 3 times so far, because like
wow.
she's just sitting there in her bed. But it's more like, you know, like changing her ice, getting her beds, and all that stuff. If I'm ever in a hospital, I'm very, very appreciative of the staff.
Yes, you will.
That's for sure. Yeah. But I think I think the 3 or 4 days after surgery are the worst. And so she seems to be getting better. Yeah. Anyway, and they're in school during the week, so I have some daytime break. Anyway, yeah. So breakthroughs. Yeah, I don't know. I'm just still getting going. That's all. Ask me later, I guess. So.
All right. That's okay. I mean, as many of you may know, like the whole curriculum was super. It was difficult for me. It takes me more reps with anything. Basketball, jokes. You know, my jokes don't usually go for well with my wife. I usually test them out on her first, and then test them out on like my kids. And my kids usually laugh, and then my wife laughs. So, like with computer science, it's just going to take a lot of reps. Like Obeda was saying, like you didn't even realize because your mind probably was on other things, you know. But the ones and the zeros, unless you're putting together hardware like my man over here, like you're not going to be thinking about that. But yeah, so I'm really happy that everybody just put in the work. Unfortunately, Tiny's not going to move forward with us, but you know she's still part of our team, and if she needs anything, you know, it's nice that y'all are willing to reach out and to help her with anything. I guess let's see. As for today, I figure we could talk about anything that was still confusing, or we could just jump into a Project Euler problem, which we haven't done in a while, and I miss those because I feel like those are nice to get the blood flow going. But Luis has already got the blood flow going. He needs to probably take a nap. Well, he's like feeling sick, huh? Yeah. So is there anything that's unclear? Oh, NyQuil. Ready to chug it? Shots.
Dayquil.
Dayquil. Okay, yeah, keep you up, yeah. Man. Anything that's still particularly confusing? I know like the spec, like that, there's just so much there. And it's actually counterintuitive what Brady said. He said, I don't want you to read through the whole spec before you start the project. But we've always been told by every previous instructor, make sure you read through the whole README. But now the spec is part of like that README, right? But yeah, you should just kind of go through the README and then just skim through the spec and kind of piece things together. You have to like puzzles, man. Gotta like puzzles. Bryant, Jade, Catherine, Lisa, anything that wasn't, I guess, crystal clear that I can try to analogize for you somehow? No. Nothing. Okay. Let's do a quick Project Euler problem. I guess, you know, I haven't led in a while. Let me lead. Let me lead the way. Just because I haven't in a while. And let's see what we can do. Let me get the problem for us here. Which one did we leave off on? Largest product in a series. Is that the one we left off on? Number 8. Or a special Pythagorean triplet. That'd be number 9.
I think we did 8.
8. Okay, so we're on number 9 then. Okay. All right. No problem. Let's see if we just get the pseudocode in this bad boy in 30 minutes. Just like your regular interviews. I just want to get that pseudocode down. Let's drop this here.
In interviews, we don't have to solve the problem. We can just do pseudocode.
No, you do. But what Brian was saying is that in an actual interview, like even if you get the question wrong, if you can demonstrate that you can take a really, really complex, large problem, break it up into parts, plan how you're going to do it with specific steps, and then you go about doing those steps, and let's say you get the wrong answer, like you still demonstrated that you can think about a problem and all of its constraints, like coming at it from every angle, and then you've like created a solid plan, and then you went ahead and like implemented the plan, even though you may not know all the syntax. Like that's still super, super valuable of a skill to have. Like imagine you before you knew Uber. Like how would you even approach a problem, right? You'd be like, I think I would dot reduce. No, like you're like sitting there like reading the problem and stuff now. So let me drop this in the channel. Okay. Let me pull up my code here. All right. Share my screen. You guys see my screen okay? Yeah. Okay, let's see. I got a lot of files, if you can't tell here. So this is something that y'all should definitely do. So I've created a repo for myself, and this repo has a ton of different, can you guys, should I make it bigger? Does that need to be bigger for you guys to see?
The
No?
print a little bit.
Okay, yeah,
Please.
no problem. There you go, how's that? Better
Perfect.
or more?
Perfect,
more. Okay.
thank you.
Okay, yep. So yeah, I do a lot of different problems from a lot of different places, and let's just throw one in here though. All right, so this is Project Euler number 9, right? You guys want to do it in Python or JavaScript?
JavaScript.
JavaScript, okay. The people have spoken. All right. So usually when I do a problem in JavaScript, let's see, my files in there. Okay. First thing I'll usually do is I like to use the assert library. So const, and that's for testing. So one way you guys can set yourself apart from the competition in an interview is to always make sure that you test your code. And so if anybody who hasn't used assert, it's a you can find it in the Node.js library. It's just like the ability to test certain things. And I like to use a special method from the assert library called deep strict equals. And I'll show you what that is. But in order to use that, you have to use a special statement called use strict. And I'll explain more of that later. Okay. Let's copy in this. Oh, there's the answer right there. Okay. So a Pythagorean triplet is a set of 3 natural numbers, a which is less than b, which is less than c, for which a squared plus b squared equals c squared. This might sound familiar. For example, 3 squared plus 4 squared equals 9 plus 16, which equals 25, which is 5 squared. Hence a squared plus b squared equals c squared. There exists exactly one Pythagorean triplet for which a plus b plus c equals 1000. Find the product of A, B, and C. So using this, find this. Okay, so you guys lead the way. I will just type for you. So what's the first thing we want to do here? What do we need to understand?
I would first put the problem in the file to reference it. Like a
Good
note.
call.
Comment.
Good call. Yeah. Don't look. Try not to look at that answer. Okay.
Oh, you still need to solve it.
Yeah. You're right. Okay. I just muddied everything up here. Sorry. I don't care what anybody says. Typing in front of a lot of people is always going to be nerve-wracking. Doesn't matter how many times you do it. Okay. I'm sorry. I'm a little OCD. I have to make it like all the stars straight. Okay. So what do you guys want me to do first?
What's that number 52? 25.
That should be 5 squared.
Oh.
Like this. Yep. 3 squared plus 4 squared equals 9 plus 16 equals 25, which is 5. Yeah. Okay.
The same for line 9.
Thank you. Line 9. Yeah. Okay. Can somebody also keep track of time too? Maybe give us like a 15-minute warning when we hit the 15-minute warning. Okay, understand. What we need to understand first.
So we can go ahead and put the definition for natural number.
Okay.
Break what they're asking.
Natural. Okay. So what do we got for natural number?
Positive integers.
Okay.
Whole numbers.
Positive integers. Whole numbers. Okay. Actually, I like to do it like this. Okay. Next. What else we got? Anything else we need to know?
Inputs.
Inputs. Okay. Is everybody familiar with like the Pythagorean triplet? Like, do we need to talk about that, or is that pretty self-explanatory there?
It looks like A has to be less than B, which has to be less than C.
Mm-hmm.
So
I think that's important to note. That's a good call. Pythagorean triplet. So consists of 3 numbers. Numbers must be, so are they all different? Can they be equal to one another ever?
no.
So numbers must be unique, right?
And of value that goes like that.
Mm-hmm.
Whatever that word is.
Okay. Like that. Anything else you guys want to put down for Pythagorean triplet?
The sum of a squared and b squared has to be equal to c squared.
Very good. Well, the sum of a squared plus b squared must equal c squared. Okay.
And we're taking in one output and we're doing input, and then we're pushing out one output.
Okay.
Which is the product of A, B, C after it meets all the above requirements.
Okay, I'm sorry. Can you repeat that one more time? So our expected input is just one input?
Yeah. And then our output is the product of all three numbers after they meet the above requirements.
Okay, and then what exactly is our expected input? And then how, I guess, what is the data type of it as well?
It's supposed to be that number right there where it says 1,000.
Oh, this one right here?
Isn't that what it's supposed to be? Or is that just an example that they gave us?
Whatever you guys want.
I'm confused then, because it says there's one Pythagorean triplet which A, B, and C equals 1,000.
Mm-hmm.
Find the product of A, B, and C. So A, B, and C are some numbers that ascend in order and are all less than 1,000.
Mm-hmm.
Some numbers that ascend in order and all equal 1,000 when added together. So that means our, whatever our C is.
Mm-hmm.
Oh man, hold on.
That's why I'm like with the squares and everything.
So do you guys want to do, should we take a look at this example again here that they give us?
Yeah.
So like if we look at the example, right? So A is 3, right? B is 4. C is 5, right? So then A squared is what? 9. B squared, 16. C squared, 25, right? So we know that these two, when squared and summed, add up to this square here. But what they're talking about here is whatever the value of all of these added up is.
Our example would be 12.
Yeah. Okay, so then let's do this. A plus B.
So are the numbers only one integer apart?
These?
Yeah. Well, like, see how the step is just 1, and it
Mhm.
grows by 1. Does that also like a requirement?
Do they have
I don't
to
know.
be concurrent?
That's what you're asking. Let's test it. Let's test it. So if you did, let's say you did A is 5, right? B would be 6, right? Would C equal 7 in this case? Because squared, this is what, 25 squared, 36, right? You square this, what do you get? 49. Is that right?
Yeah, but they're not Pythagorean triplets.
Right.
So what I'm saying is, like, if they're like these Pythagorean triplets happen to be incrementing
Consecutive.
and consecutive,
Right. Mm-hmm.
does it have to be like consecutive, like by 1 increase as you go along?
I don't think so. If we look at the objective, right? So usually that's what the first thing I was typing up here in the understand. Where did I type it? Oh, it's down there. So like I usually like to start with an objective, right? Because if you have a mission, like let's say you're on a mission, like you want to know what your mission objective is, whether it's to go and capture the enemy's flag or whatever, like when you play a game like that, you want to know what the objective is. So you just need to find what A, B, and C are, right? And then you need to just find the product of that. So you know the end result of these. So if we use this example here, how can we reverse engineer this to get to this? That will allow us to reverse engineer this to get to the A and the B and the C. Right? So let's go through the steps. How do we get 3, 4, and 5 from this number right here? I'm going to take this and put it down here. You understand. Okay, so how do we do that? how do we take what they've given us? So Louise said this is 12, right? A plus B plus C. So the actual product of A, B, and C in this situation would be what? Come on, peeps. Computer science wasn't that hard today. Come on.
75, I think.
75?
Oh, I don't know.
That's
Everybody
I'm
agreeing
not sure.
that? Come on, guys, we got computers. They could run these.
3 times 4 is
70?
12. 12
Yeah,
times 5.
60.
Oh, whoops, I said
60.
Okay. Sorry. We'll give Luis a break. He put a computer together and he's like sick right now. So
I said 70.
he's probably drank some NyQuil, some Dayquil too. Okay, so 60, right? So we know that, so this is the answer we would arrive at if we put, if instead of 1,000, we had 12. Instead of 1,000, we had, yeah, this 12 right here.
So if you divide 60 by 12, it gives you C, and then could you just, then you would just have to figure out what A and B is, since A and B is A squared and B squared is always going to be C equals C squared.
Okay.
I'm
So-
just blabbing, but that's
No,
what I'm
that's
thinking.
that's good. So what was the next step then you said? You said you took 60 and you divided by,
By 12,
uh-huh.
and that gives you 5. But I
Okay.
don't know how you derive. I mean, if you're looking still just at the sum, then you would just have to like
so,
figure out.
so
Go
A
ahead.
plus. So you're saying that we could just say A plus B equals something that's divisible. I was trying to follow you. And then,
I'm just trying to follow what you're saying. I'm writing it down. A plus B, what are you saying?
well, because what Jay was saying was like starting to click something, and now.
Well, because we're talking about how we can reverse engineer if we
Yep.
we know that the sum is 12, the product is going to be 60. So, and just looking at A, B, and C, what we have, you divide 60 by 12, that gives you C, and the only thing you'll have to figure out is, we know 3 and 4 is going to be 12 on its own, right? Like, I don't know if I'm confused. Oh, no, that's multiplication. Never mind.
We're not going to know the product.
Yeah, never mind. Just kidding.
Like we have the advantage of knowing the product here for the example, but we're not
We have
going to
the
know
product.
it.
We have the product right here, right? Or no, we have the sum right here.
That's
Okay.
the
Yeah, it's a
sum,
sum.
yeah.
Okay. So we need to switch up our approach then. That was my fault. I thought that was the product. Okay. So let's say we have the sum then. So what would our product then be? 60. It'd still be 60. Yeah, it'd still be 60 right here, right? Okay. So we have to take the sum and then, oh, that makes things easier then, right?
The sum is the product of 2 of the numbers.
Oh, this sum is the product of 3 numbers, A, B, and C together. Right, so like in our example up here where they have like A squared plus B squared plus C squared, that's 3, 4, and 5. When you add those together, that makes 12. So then from 12, we're able to derive 60 because 3 times 4 times 5 is 60, right? I
But
got 12 minutes.
The sum should be divisible by the product or something.
Sum divisible by the product.
So this
So
product 60 is divisible by the sum.
So we'd have to test that, or
I don't know. I'm just trying to.
oh, okay. What can we, like, thinking back to like 8th grade math, right? Like if you have A squared plus B squared plus C squared, like what do you need to do in order to get to start combining, I guess, like terms and oh, Beta, where you at, man? Like this is your specialty.
Simplify.
Simplify. Okay, so how could we simplify here?
Well,
And if we can't simplify, can we make the computer do it for us? Maybe that was a
Square root of both sides of the equation.
Okay. That's a good idea. That's a good start. Right? So we're gonna square root this. And then what is that gonna do for us?
Oh, I was thinking about the a squared plus b squared equals c squared.
Okay. Well, I'll just do it right here. I'll do it right here. Look, a squared plus b squared equals. Okay. There you go. So then this would still, that would not be the sum anymore. Okay. So you're saying take the square root of both sides like this? Like that, Catherine?
Yeah, but I don't know if you can even do that. Listen, I'm.
Bryant, man, you've been kind of quiet over there. I know your wheels are turning.
Yeah, I'm trying to think how simplifying it would help. Then you would get c equals the square root of a squared plus b squared. You can't, right? It doesn't, can't reduce it to a
We could
plus
move
b. You can't reduce the
A
a
at like a plus 1 and B at a b plus 2. C at a c plus 3. Could you further explain this, sir?
Yes, there's background noise for a sec. Yeah,
Okay.
so I'm just muting myself in the middle of my talking. But essentially, it would be we can move down the list and test. So if a squared plus b squared equals c squared, and then from there we see if a times b times c equals 1,000. And then if not, then we move on to the next one. We move again +1 +2 +3. And
There you go. So
that.
we're using iteration then, right? Like we're going to iterate 3 different variables then? Is that what you're thinking?
Yeah, but they're all iterating at different growths, I guess. One is iterating at a plus. I mean, I didn't do the math. I'm just thinking in my head, right? Like you have one moving at a slower rate because it's the smallest number, and then one moving a little faster than it, and then the last one's moving the fastest and it's climbing up because the idea is the largest number has to be C, and the middle number has to be B.
No matter what, right?
No matter what, it's always going to be in that order.
So let's
But
just
I
like
haven't
throw.
done the math, so I don't know.
Okay, let's just throw some code up that looks like code. Okay, so for I in, or we're doing this in JavaScript. My bad. For let I equal, let's say 0, or I can't equal 0. It'd be 1. Let's say A. Okay, and then A is less than B, right? We'd have to like declare these variables up top. A is less than B. A, we're going to keep incrementing it. Okay, so then what would it look like inside of here? Would we do another for loop? Like what's our game plan here? Because you said you want to iterate this, and then like the next thing would be like this, Beta?
Oh, that's interesting.
Right,
No,
so then like
I didn't think that's actually a good idea.
So then you'd always be, like B would always be more than A, C would always be more than B, right? I mean, this would be a terrible runtime, but
well, I wasn't thinking for loops nested inside for loops. I was thinking more like a
3 different variables.
A while loop that runs.
Okay.
And then like an if statement under it, and then under that you're just moving along. So so this is how I would think, right? Your while loop would be like while A times B times C doesn't equal 1,000.
Okay. So you're literally like looping. You're gonna keep looping through until this equals 1,000.
Yeah, I mean, right? We go for the first, I guess.
Okay. Okay. Yeah. Okay. Then what would you put inside here?
In here it'd be. Yeah, so this is where I would do the increment. I'd be incrementing and testing.
Okay, so are you declaring your A, B, and C outside? Because technically you have to, right? So it'd be A equals, what do you want to start at? 1, and then B is 2, because you have to start at positive whole integers.
Yeah, and then
what do you guys think? Like that?
Or we can also have a variable that makes like variable is true. So then it'd be like while true, and then the if statement under it would be if A times B times C equals 1,000 break. So it'd be two if statements. So if A squared plus B squared equals C squared, then we test to see if A times B times C double equals 1,000. If it does, you break out of the while loop, or you just return the product of all three.
Is it time or sum?
We're trying to find the product of the
times.
three numbers, but like we have the sum, right?
So we're testing for A plus B equals C equals 1,000.
Mm-hmm.
Trying to find the product.
Mm-hmm.
Because on 52, it's times equals 1,000. That's why I was confused.
Oh, yep. I'm sorry. There we go. Like that? Okay. And then we're going to say here, if A squared plus B squared equals C squared. Okay. We got 4 minutes to get this pseudocode in here. What do you guys think here? Okay, so something like this. What's next? So we're iterating through, what's the condition? Actually, Beta, you wanted this to be like a while true, yeah?
That could say, well, A times B times, is it times or plus?
This is plus, I'm sorry.
It should, yeah, no, that's right. It should say not equals though.
Not equals, okay. Is that big? Is that big enough now? That should be good, right? Okay. Or is that too big?
Oh, that was just like your linter, I see. Weird.
What's that?
Just looks weird on my screen, but that's my.
Do you want it?
No,
you're
good.
Down. Okay.
You got this.
All right. What's next, folks? 3 minutes here. You guys just brain fried, huh? Catherine, you look like you're falling asleep right now. Brian, you look like you're interested in the problem, but you're like also thinking about carrying your wife up and down the stairs too. Luis is ready to take a nap right now. So I know this sounds like a terrible idea, right? But like the nested three nested for loops.
I was thinking about that and how you could be like throwing a condition like with C equals the square root of A squared and B squared,
yeah.
Then that's a triplet.
Mm-hmm. Because like putting that, my first instinct was to go 3, 4 loops nested inside each other, even though that sucks horribly runtime. But it would at least give you access to 3 incrementing variables where like A would always be less than B, right? B would always be less than C. C would always be more than B and A. So I mean, that was like my first go-to. Like that, right? And then C is, as long as C is greater than, actually, C would never get greater than the number that we're taking in, right? The sum. So this would be like our one input. C could never be greater than this, right? I feel like y'all are here, but not here.
Yes, you're right. Both counts.
With 1 minute left to go here, we can just we'll solve this the rest of this tomorrow.
And then while C is less than 1,000, C plus in the on line 59.
Yeah.
C is less than 1,000, C plus plus.
Oh, C plus plus. That's a nice little reference to programming language. Huh? Okay. Is that right? Okay. So then what would you put inside here, the for loop here?
I would do an if statement if something A plus B plus C equals 1,000 break.
Break.
Return an array of A, B, and C.
Thank you.
Very good, man. Saved. Return an array. Yeah, that's what y'all are thinking right there.
Then we at least know what they are, or we can return. We could just return A times B times C and have it spit the answer out.
That's true. A times B times C. Okay. Should we try her? Actually, you know what? This is like bad form because like we didn't even. We should just run it though, huh? Okay, just right here. Okay, great. This is where you got to use this trick right here. It's not the trick I wanted. That's the trick I wanted right there.
What's the hotkey for that?
It is Command D, but now it's going to get rid of
D.
the A, B, and C right here.
Okay.
Yep, Command D. Yep.
Thank you. I was trying to figure that out yesterday.
Oh man, it's so helpful. Okay. I don't know why my linter's not working right now.
Do we need to like put it in a function or something, or to call it, or I don't know.
Yeah, we probably should. Okay, let's just call it find Pythag pi trip. There we go. Find pi trip, and it takes in a sum. There we go.
But then you need to change the thousands to some.
Very true. Good call. Okay. So we gotta console log this. Find with that. Don't even have to type it. Pass in the sum of. Let's do 12, huh? Did we do? Was it 12 before our old sum? So then it should be 60, right? Okay. Let's run this bad boy really quickly here. No. Unexpected token. Okay. Oh, thank you. Gonna put a comma right there. I knew that. Come on. E is not defined. Oh, we didn't. Yeah, we gotta. Got A. What are we gonna start these? Got B. Let's see. Okay, we have undefined here. It's 8:03, and I don't want to keep any of you guys any longer. Your face looks. Everyone looks very tired. So let's just continue this tomorrow. I'll save this in my code, and then we can just resume mañana, so people can get some rest. All right.
Sounds good.
Thank you.
Thank you.
Thank y'all.
Thank you.
All right.
See ya.
Bye.
All right.
Oh, beta. Okay, so if I'm going to go ahead and continue this problem, the way that I would have done it is I would have, let's see, Pythagorean triplet is a set of three natural numbers, a plus b plus c, for which a squared plus b squared equals c squared. We always know that a will be less than b, which will be less than c. So my theory is that we can increment a, b, and c together in a for loop with nested for loops. Terrible runtime, but it's a good brute force solution just to get something going. We can even go ahead and print these out here. So we can do a console.log. Let's do a a equals, let's do a template string with the money sign. Okay, and then we could just copy that. Let's go put that here for B. Same thing. Okay, and then we could do the same thing for C. Whoops. Here we go. And if we pass in, oh, this actually I need to put it in at my comments. Here's where I need to put it in. Okay. Copy this one here. And this one here, so we can get a better idea of what it is that we are multiplying together. Yeah. Okay, and let's see. So we need to have an if statement that handles this. So if sum, so if a sum exists, then do this. Else, say return so if sum, we're going to return A, B, and C. Actually, this is just the example, so we're not actually, we're just trying to find the logic involved in this. So we're still getting undefined here, so find PyTrip. Let's do this. Let's do A equals 1, B equals 2, C equals 3. Let's do I equals A, J equals B, K equals C. Is that possible now? So then this would be I. This would be I. Actually, let's do Control D and get the B's there. So that'd be J. This would be K. Whoops. Okay. Now, hi. How you doing? There we go. We got something to print now. Okay, I'll be right back. Need to go put my daughter to bed.